11.1 is circumference and arc length of circles. And what we're going to start off with are a few vocabulary terms. The first one is circumference. You should know what it is already because of from Algebra 1. And the official definition we could use is distance around the outside of a circle. There's an equation that you should be familiar with. It's uppercase C for circumference is equal to 2 pi r. All right, so if you forgot what that is, make sure you guys put that into your notes. Next up, we have arc length, and that's the distance between 2 points around a circle, or that happens to be on the circle. So if I'm going to go ahead right here, if I have myself a circle, and I've got, let's say, here's my circle, and I have right here a point A, and over here on the circle we'll put point B. If I'm going to try to find the arc length, I want to figure out how long is this distance right here between the 2 points, or arc AB. Right, so that is the arc length. Next up, we have the term radian. Now, a radian is used as a particular measurement of a circle. It's the same thing or similar to that of degrees. So if I were to say, if I were to talk about like 50 degrees, I'd be able to take that 50 degrees and convert it into what we call radians by multiplying it by particular value. It's a conversion. So think of it similar to that of if we have temperature. If I have Fahrenheit, if I multiply it by particular using a particular equation, then it will take me to Celsius, and I can calculate from degrees Celsius to degrees Fahrenheit. So that's the same, similar with radians. I have a degree, I multiply it by an equation, it'll turn into radians. And then vice versa, where if I have something in radians, I'll multiply it to get myself degrees. And we'll talk about more of that later on in the lecture. As we go down right here, so once again, circumference of a circle, we have 2 pi r is the typical term that or equation that we use. We could also use right here circumference is equal to pi times d. Okay, so 2 radii will equate to the diameter, so that's why you could use either of the two equations right there. So we have our equation that we're going to be using to help us find the arc length. This right here is something that you need to be familiar with and memorize, and it's arc length of AB over 2 pi r is equal to the measure of the arc AB divided by 360. So go ahead and put memorize right there. So what they're saying is that if I want to find in our diagram, I'll highlight in red, the measure of arc AB, there are several things I need to know. First off, I have to know what the radius is. So they'll give us the radius. And then what they also need to give us is this angle right here. This angle, don't forget, is what we call the central angle. And this angle is equal to the measure of the arc. So when I look at this equation, and for me to what helps me memorize like what are the different parts of our proportion that you see here. Uh, on the left side over here, what we are dealing with is length. And so all we're going to have on the left side of this proportion is measurements, particularly lengths. On the right-hand side over here, what you see is, look at this, there's this 360 degrees. Well, what we're going to be using over here are measurements in degrees. And don't forget, the measure of arc AB is equal to that of the central angle. The last part to this lesson right here is converting from degrees to radians, radians to degrees. All right, it's a very simple calculation. And right here, all you need to do in order to go from degrees to radians is by multiplying whatever you have. Let's say if I have 100 degrees, I would take 100 degrees and multiply it by 2 pi over 360, or you could multiply it by pi over 180. Now, I would choose this right here to multiply it by because the numbers are smaller, right? 2 pi over 360 is equal to pi over 180. All that happened right here is that this is the reduced form. So you take your angle measurement, multiply it by pi over 180, and you will have your number in degrees, or sorry, radians. Now, for us to go from radians to degrees, you're going to take, starting off, you'll have something in radians, and usually it'll have pi involved. So we could have like 2 pi or 3 pi over 2. And I want to take 3 pi over 2 and convert that to degrees. I'll go ahead and multiply that by 180 over pi. And what you'll notice happening and why it works out nicely is that pi happens to cancel out. Okay, so let's say if I have 3 pi over 2 and I multiply that by 180 over pi, you'll see right here, pi's cancel. This right here, we can simplify, that becomes 90. And so you're left with 3 times 90, which is 270 degrees. All right, so it's a very simple calculation as long as you know whether you're supposed to multiply by degrees, uh, convert from degrees to radians, or radians to degrees. The thing that usually helps me out in remembering, all right, do I need to multiply by 180 over pi or pi over 180 is, especially for radians, if I want to get rid of that pi, then I want to multiply by 180 over pi so I can cross cancel. All right, if I multiply this by pi over 180, then the pi's will not disappear, and you're going to get some number that you'll never have seen if you do the homework. Okay, so, and a number that does not make sense. Let's go ahead and take a look at how we're going to solve some of your homework questions. Problem number 1 right here says the diameter of a circle with a circumference of 10 inches. Now, if they talk about circumference, that should be a dead giveaway of which equation we need to use. We have 2 of them. Remember, we have circumference is equal to 2 pi r, which I could possibly use. Or, remember, we also have circumference is equal to pi times d. And this would be a better one to use right here because they're saying we want to find the diameter of a circle with circumference of 10. So now the last thing is let's go ahead and figure out, well, what other information they gave us. They gave us the 10 inches, and we got to figure out, well, where does that go? Well, circumference of 10 inches should hopefully help us to put and substitute 10 in for c. And then that is equal to pi times d. Well, I'm trying to solve for the diameter, so it's perfect. And all I need to do, we'll divide both sides by pi. And my answer is diameter is equal to 10 divided by pi. Now, they may ask you for exact answers, and this would be the exact answer. I believe in big ideas, they actually have you round to the hundredth. Okay, so round to the hundredth. And if you use your calculator and take this and round to the hundredth, you get approximately 3.18 inches. And that would be the diameter of the circle. Let's take a look next at number 2. This time it says the circumference of a circle with a radius of 3 centimeters. So we have circumference is equal to 2 pi r, and I would always start off with the equation that we are using or that needs to be used in order to solve things out. Because then all you need to do is, all right, let's take a look right here. It said with a radius of 3 inches or centimeters. So that right there tells me, let me go ahead and plug this in for r. And we'll go ahead and simplify this, and we get ourselves 6 pi. That would be the exact answer. However, you may find once again in big ideas, they want an answer that is rounded off to the nearest hundredth, and this ends up becoming 18.85 centimeters. All right. Let's take a look at number 3. This one says that they have the radius of a circle with a circumference of 8 feet. So this time around, circumference equal to 2 pi r, but they give us the circumference of 8 feet. So I want to have to plug in 8 for c, and that's equal to 2 pi r. By doing this right here, let's go ahead and get r by itself. Well, in order to do that, we'll divide both sides by 2 pi, and that cancels out, and then we can go ahead and simplify this to where r is equal to 4 over pi. Right? 8 divided by 2 is 4. That's going to stay in our numerator, and pi will stay down below. We go ahead and plug that into your calculator, and this will be approximately 1.27 feet. And that's the radius of the circle. Okay. For number 4, pretty much the same thing, except we would use the equation with pi, or circumference is equal pi times d, and that will help you get to your answer. So we won't do that right there. I think you should be able to do number 4 at this point in time. Let's look at number 5. They want us to find the arc length of AC. All right, so we are trying to figure out, well, what is the length of A to C? So that's where we use our equation. Remember, it was arc length divided by 2 pi r is equal to, we have the measure of the arc over 360. Remember, I was telling you, the left side right here is going to deal with measurement, length. Over here, we're dealing with degrees, angle measures. So let's see what we have here and what we could plug in. I have this 3 inches. That right there would be your radius. So let's go ahead. I'll plug in 2 pi times my radius of 3. And there you have that part. The arc length is what we're going to find. I'll go ahead and substitute x in right here. And now let's figure out, well, what's the measurement of our arc? Remember, this is arc AC. From a chapter ago, we figured out that the measure of this arc is the same as the central angle. So if my central angle is 70, the measure of this arc right here is going to be 70 as well. So we got 70 over 360. And then you can go ahead, cross multiply, and solve things out. Okay, so that would be our next step. We cross multiply this way, x times 360, that gets me 360x. You multiply this way right here, I'd take 70 times 2 times 3, multiply all of that together, and then that'll get you a total of 420. And so when we cross multiply this direction, we'll end up with 420 pi. Our last step, I would hold off to the very end before you plug pi into your calculator so you don't have to deal with any rounding errors and um, just long numbers. Is let's go ahead and get x by itself and divide both sides by 360. So x right here ends up equaling, it's around 3.67 inches, and that right there is the length from A to C, or the arc length of AC, 3.67 inches. Okay, so make sure on these problems, I'd definitely start off with the equation and then see what they give you, and then plug things in and then solve out for whatever part of the equation you need to solve for. The challenging problems will give you arc length and the measurement of the arc, but then you're going to have to find the radius. And that'll take a little bit more work. You may see that in your homework. All right, last up, we're going to go ahead and convert degrees to radians, radians to degrees. So if they want you to take right here 60 degrees and convert that to radians, remember, we have two options. We're either going to multiply something by pi over 180 or 180 over pi. Now remember, if I'm going to turn something into radians, you're going to have pi in the answer. So if I'm starting with degrees right here, this 60, I'm going to take and multiply this by pi over 180. Okay. Think about what's across from each other right here. Degrees. Technically, the degrees will cancel out, and I'm left with pi or my radians. So this right here, you definitely want to, you can go ahead and just leave this in terms of pi. Make sure you simplify this. So we got 60 pi over 180. And when we simplify this right here, this becomes pi over 3. Right, the zeros cancel. 6 over 18. We could divide top and bottom by 6 and end up with 1/3. So pi over 3 is the same thing as 60 degrees in radians. When I take a look at number 7, we're taking from radians to degrees. So earlier, I talked about right here, I want to be able to, if I want to have something in degrees, I can't have pi in it. So if I look right here at the two equations that we could multiply by, what I will multiply this one is multiplied by 180 over pi. Because what ends up happening right here is that pi cancels out nicely. And then we can go ahead and simplify even more, and you can reduce it down. Okay, and so right here in the end, this ends up equaling 150 degrees. And that's how you go from radians to degrees and then degrees to radians. Make sure you know these two equations right here and know when to use what. All right, there's section 11.1.